Let's see where cubes or multidimensional databases fit into today's data warehousing. We've already seen how relational database management systems, RDBMSs, are typically the default platform for our data warehouses and data marts, but also we've used cubes for a number of years as an alternative platform. First, we need to explore exactly what a cube is and what it's not. First, it is definitely not a relational database management system. Instead, a cube or a multidimensional database is a specialized database that has inherent awareness of this idea and concept of dimensionality of its data contents. In fact, for first-generation data warehouses, cubes were a leading alternative to relational database management systems. Products of the day such as Express, Essbase, PowerPlay, all of which were sort of hybrid BI data warehousing products, were instead built on cubes rather than relational database management systems. Cubes are still used today, but also they tend to be used primarily for smaller scale data warehouses and data marts rather than larger enterprise scale systems. When you use a multidimensional database or a cube, you do have some advantages, one of which is very fast query response time. Cubes do tend to be best for modest data volumes with the definition or ground rules for modest changing over time, but think of, let's just say, 100 gigabytes of data or less. And that sounds like it's a lot, and at one time it was a lot of data for a data warehouse or a data mart, not today when we consider the volumes that we typically will have in a data warehousing environment. On the other side, though, a disadvantage of cubes is that they are less flexible than when we use a relational database management system. Essentially, what we have, or what cubes give us, are a very rigid organizational structure for our data that is built for that fast performance for the queries and reports that I mentioned. But the structural changes to the data, once you set it out in place the first time, they do tend to be far more complex and more time consuming than with a relational database management system. You also tend to have far more vendor variation with cubes than you do with relational database management systems. And therefore, what we often find today are data warehousing environments that take advantage of both relational databases and multidimensional databases or cubes. Consider this picture, which we've seen a variation of this several times, where we have a data warehouse that is feeding data into a series, or in this case, 3 downstream data marts. We could have the data warehouse built on top of a relational database management system platform, but each of the data marts is instead built on top of a cube. Or maybe you have a mix and match architecture where one of your data marts is built on, let's just say, SQL Server or another relational database. The other 2 data marts tend to be built on cubes. From a user perspective, what we do try to do, just like with data lakes and data warehouses, and for that matter, data virtualization, we try to abstract them away from the underlying data architecture, because instead of using native SQL, or for that matter, accessing the data environments and tables directly, or whatever the data structures are, what we do typically try to do is use BI and visualization tools such as Tableau and Microsoft Power BI. So in general, cubes, along with relational databases as part of your overall data warehousing environment, they can be, if it makes sense for your organization, a really powerful combination.